Christmas Eve, 1938. A physicist is sitting in the snow in Sweden, working through a calculation on a notepad balanced on her knee. She has been exiled from her laboratory, stripped of her citizenship, and crossed a border with 10 marks and a borrowed ring. The letter she received days earlier came from the institute that expelled her, asking for a fantastic explanation. She finds it that afternoon. The explanation will reshape the 20th century. Her name will not appear on the prize. To understand what was taken from Lise Meitner, you have to understand what she built. In 1907, she arrived in Berlin and began working with the chemist Otto Hahn at the Chemical Institute of the University of Berlin. Its director, Fission, did not permit women in his laboratory. Meitner was given a converted carpenter's workshop in the basement, on the condition that she never set foot on the upper floors. She used a back entrance. To reach a toilet, she left the building and walked down the street. In 1912, when the Kaiser Wilhelm Institute for Chemistry opened in Dahlem, Hahn was appointed there and invited her to join him. The collaboration that began in that basement would last 30 years. That is not a footnote. That is a career. By 1918, Hahn and Meitner had co-discovered protactinium, element 91. Her name is on that paper. The partnership was real, documented, and scientifically productive. This is the baseline you need to hold as this story develops, because what follows is not a dispute about whether she contributed. The record is clear that she did. The question is, what happened to that record? The institutional context matters too. Meitner was Austrian. Her Austrian citizenship had been, in practical terms, a legal shield inside Germany. She was Jewish by origin under the definitions that Nazi law would eventually apply, though she had converted to Lutheranism decades earlier. The law, when it came for her, did not care about her faith. It cared about her ancestry. And in March 1938, that legal shield disappeared overnight. The Anschluss, March 1938. Germany absorbs Austria. At a stroke, Meitner's Austrian citizenship ceases to exist. Under Nazi racial law, she is reclassified. She is now a German Jew without legal protection, inside a country that had been systematically removing Jewish scientists from institutions for 5 years. The position is not ambiguous. It is dangerous. Inside the institute, a chemist named Kurt Hess, a committed Nazi, is saying openly, and this is his phrase and not mine, that the Jewess endangers this institute. And Otto Hahn, her closest collaborator for 3 decades, capitulates. He tells her she can no longer come to the institute. Meitner writes in her diary, "He has, in essence, thrown me out." And then, in those same weeks, Hahn works with Karl Bosch, Peter Debye, and Dirk Coster to get her out of the country. Both of those things are true. That is the shape of this entire story. The plan that finally succeeded required moving her across the Dutch border without an exit visa, because she did not have one. On July 13th, 1938, Lise Meitner left Germany. She carried one small suitcase. She had approximately 10 Reichsmarks, essentially nothing, the maximum she could legally take. And she carried a diamond ring that Otto Hahn had given her. It had belonged to his mother. The ring was not a gesture of sentiment at that moment. It was a practical object. If a border guard needed to be bribed, the ring was the price. The physicist, Dirk Coster, escorted her across the border into the Netherlands. She did not know at the crossing whether she would be stopped. She was not. She eventually reached Sweden, where she had been offered a position at the Nobel Institute in Stockholm. She was 59 years old. She had left behind 30 years of work, her laboratory, her instruments, her library, her home. Hahn kept his position, he kept his institute, and in time, he would keep her name off the result that defined both of their careers. But that result did not exist yet. 5 months would pass. Now, a brief interruption in the timeline, because Lise Meitner was not the first woman to point toward fission and be ignored. In September 1934, the chemist Ida Noddack published a paper in Zeitschrift für angewandte Chemie titled Über das Element 99. In it, she suggested explicitly that when uranium is bombarded with neutrons, the nucleus might not merely shed small particles, it might split into large fragments. This is, in conceptual terms, the idea at the center of fission. The physics community ignored it. Emilio Segre later acknowledged that she had pointed this out to researchers directly, and they had not followed it. Part of the reason was credibility deficit. Noddack had previously made a disputed claim about element 43, which damaged how her work was received. Part of the reason was that she offered no theoretical mechanism to explain how a nucleus could divide that way. Without the mechanism, the suggestion remained speculative. Both of those factors are real and worth stating clearly, because flattening the history into simple dismissal misses the point. The point is this: two women, 4 years apart, identified the same phenomenon, and the field moved past both of them. The silence was not identical in cause, but the result was the same. December 1938. Meitner is in Stockholm. She receives a letter from Hahn. He and his colleague Fritz Strassmann have been bombarding uranium with neutrons, and they have found something that should not be there. Barium. Barium has an atomic mass roughly half that of uranium. Under the prevailing model of the nucleus, bombarding uranium should produce elements close to uranium in mass, not something half its size. Hahn is a careful, experienced chemist. He has checked the result. He writes to Meitner, asking for what he calls a fantastic explanation. Read that again. He is writing to the physicist he had told, 5 months earlier, that she could no longer set foot in his institute. He is writing because he needs her. She is spending Christmas with her nephew, the physicist Otto Frisch, in Kungälv, on the Swedish coast. Frisch arrives expecting a quiet holiday. Instead, Meitner is already thinking through the letter. They go for a walk in the snow. At some point, they sit down on a log, and Meitner applies a model she and Frisch both knew well. Niels Bohr's liquid drop model of the nucleus, which treated the atomic nucleus as behaving, in certain ways, like a drop of liquid under surface tension. If you add enough energy to a liquid drop, it deforms, elongates, and eventually splits. She works through the numbers. If a uranium nucleus divided into 2 roughly equal fragments, the mass of the products would be slightly less than the mass of the original nucleus. That mass difference, small but real, would be converted to energy according to Einstein's equation. She calculates approximately 200 million electron volts released per fission event. That figure is consistent with what the experiment implied. The nucleus was not chipping, it was dividing. This was fission. Frisch would later coin that term, borrowing it from cell biology. On January 6, 1939, Hahn and Strassmann submitted their chemistry paper. It documented the barium result. Meitner's name does not appear on it. In the context of 1938, Germany, this requires careful framing. Crediting a Jewish exile in a German scientific journal under Nazi oversight would have endangered Hahn, Strassmann, and potentially the publication itself. That is a structural constraint, not an excuse, but it is a fact of the situation, because the war will end, and Hahn will still be silent. On February 11th, 1939, Meitner and Frisch published their paper, the theoretical physics paper, the one that explained what Hahn had found, the one that calculated the 200 megavolts, the one that introduced the word fission into nuclear physics. The record is split. 2 papers, 2 disciplines, 2 author lists. For a moment, the full picture is visible in the literature if you know where to look. In 1942, Meitner was approached about the Manhattan Project. Her response, as documented, was direct. "I will have nothing to do with a bomb." This is the appropriate moment to address a myth that has followed her story for decades. A 1940 article in the Saturday Evening Post, written by William L. Lawrence, the Manhattan Project's official chronicler, portrayed Meitner as having smuggled Fission secrets to the Allies when she fled Germany. The timeline makes this impossible. She left Germany in July 1938. The barium result that revealed fission came in December 1938. There was no secret to carry because the result did not yet exist. She fled 5 months before the discovery. The myth does not serve her. It reduces a physicist who refused a weapon into a plot device in someone else's war narrative. November 1945. The Swedish Academy votes to award the 1944 Nobel Prize in Chemistry. The vote, according to reports, is a narrow majority. The prize goes to Otto Hahn alone. Meitner is not included. She had been nominated for the Nobel Prize beginning, according to historical accounts, in 1924. She would continue to be nominated for roughly 2 more decades. The total, according to multiple sources, comes to 48 nominations. The physics paper exists. The 200 megavolt calculation is in the literature under her name. The theoretical framework that explained what Hahn observed in his laboratory is documented. None of it is weighted sufficiently by the committee. And then, the post-war years. This is where the moral architecture of the story becomes clear. The Nazi laws are gone. Hahn is free. He is celebrated, rightly, for real chemistry, and he speaks to the press. He presents the discovery of fission as a purely chemical achievement. He states publicly that Meitner did not participate in the key work. He is not under compulsion when he says this. The legal constraints of 1938 no longer exist. He chooses this framing. And then, in 1948, 3 years after accepting the prize alone, Otto Hahn nominated Lise Meitner for the Nobel Prize in Physics for the explanation of fission. It is in the Nobel Foundation's own nomination archive. In the formal record, he named her. In front of a microphone, he did not. That is the distinction the history requires us to hold. The 1938 omission had a structural explanation, rooted in a specific political system. The post-war silence is a choice made by a free man. Those are not the same thing, and treating them as the same thing would be historically imprecise and morally evasive. The count, when you lay it out, 48 Nobel nominations. Element 109, Meitnerium, named for her in 1997, after her death in 1968. The prize she was denied is the one most directly connected to the atomic age. Otto Frisch wrote her epitaph. It reads, "A physicist who never lost her humanity. The institutional mechanisms that allowed one half of a discovery to be credited and the other erased did not require malice at every step. They required peer dismissal in 1934, when Ida Noddack pointed at the same idea. They required legal exclusion in 1938, when a political system defined who could be credited. They required a narrow vote in 1945, when a committee weighed chemistry against physics and chose one. And they required ordinary silence in the years after, when the man who could have corrected the record chose not to. The question is not only what happened to Lise Meitner, the question is which of those mechanisms, dismissal, exclusion, selective crediting, post-war silence, are still producing the same results today in different institutions for different people. The same year, Meitner was forced out of Berlin. Another physicist was navigating the same fascist machine with a very different outcome. That story is already on this channel. If this kind of precision matters to you, subscribing means you will not miss what comes next.